What is up, everyone? Today we're going to talk about segments, rays, and distances, which expands upon our lines. We're not going to talk too much about planes today. We're mostly going to focus on lines and different ways to write it, i.e. segments, rays, and the distance of something. All right, first of all, we should start with the bell work. The bell work says name the intersection of YX and line A. Those are two lines intersecting, so they must intersect at a point. If we quickly highlight that, YX is that one, A is that line, so they must intersect at point M. So that would intersect at point M. All right, name the intersection of plane C and plane D. When two planes intersect, they intersect at a line. So if we look at C and we look at D, they're intersecting at this line right here, and that is line A. All right, continuing on to today's lesson. Today's lesson, we talked about a line before, and we're going to talk about line segments. A line segment is a portion of a line with two endpoints. A line has no endpoints. It goes on forever in both directions. A segment's going to end at both ends. Just quickly in this drawing here, we have a big line right here. Well, if I had a race, that's a bit aggressive. If I had a race right there and right there, we'd be left with a segment. No arrows on either ends. That's what makes it a segment. Let's backtrack just a second. First of all, let's review what we learned yesterday or the day before if you watched the video. If I would list something like AR, and then I put a line above it, what I'm actually doing is I'm describing line AR. So that's red line AR. I also want to quickly note that line AR is the same as I guess let's list some. It'd be the same thing as line AB. It'd also be the exact same thing as line RA. It would also be the same thing as BN. We can choose any 2 points on that line and state them in any order, and it is still the exact same line since it extends in both directions. So any 2 points, any direction, and you have the same line. What we're going to expand to next, though, is a segment. And we're going to write a segment out. We're going to write a segment AR. Notice the line I draw above it. It has no arrows on it. Since there's no arrows on it, it is read as a segment. It is read segment AR. So it's just a segment. It's got 2 endpoints. So what we're talking about in that segment is we are no longer picturing those arrows. It is strictly that distance or the range between A and R. Note, since there aren't arrows, it is just the points between A and R. So it's just the points between A and R. Well, it doesn't matter which direction you list those. So AR, segment AR, is the same thing segment RA. It's still all the points between A and R or R and A. It doesn't matter which direction you do it, it's still the distance between those 2 points. However, there are things that aren't the same. If I say segment AR, that is not the same as, say, NB. If we look at the points between N and B, those aren't the same points as between R and A. R and A is a much longer segment than B and B. Another thing that wouldn't be the same is AB. And we could think of some more along the way. So a line, you could pick any 2 points, say it's a line, and they're all the same. For segments, 2 points generally make just one segment. Any other point you pick is going to be a different segment. So lines, pretty much everything works. Segments, everything's a little different if you're picking different letters. All right, the last thing I want to talk about. If we put a line above AR, that means it's line AR. If I put a line with no arrows on it, that means segment. The last thing we're going to talk about is if I put AR with nothing above it. If there is nothing above it, what I'm talking about is distance. No line above it means distance from A to R. In other words, we're talking about a measure. I'm talking about, like 6 centimeters, 8 feet, some kind of actual physical distance. Note, sometimes these distances we'll use X for them to hold their place until we find out a value. But we're talking about a distance or a measure. The one thing that does work out, since we're talking about distance, A to R is going to be the same as R to A. But if we pick any other points, we know that distance is going to change. So it's just basically like a segment, what works and what doesn't work. All right, so we have line, segment, distance. Line has an actual line above it with arrows. Segment has a line with no arrows. Distance has nothing above it. All right, let's talk about some distances. If B is between A and C, then AB plus BC equals AC. And what we're talking about is, let's go down to the first example to see what I mean. So it says find the distance E to F. Well, based upon that statement right above, we should be able to write, and we can, that E to F is the same thing as if I take the distance from E to D and I add the distance D to F. In other words, EF is just going to equal that 1.2 plus that 1.9, which is going to equal 3.1. We can use it slightly backwards. We're trying to find the length of B to C, so this is kind of our missing length there. So let's note, if we take the whole minus a part, we're going to be left with that. So we can rewrite this as BC is going to equal the whole, which is AC, and subtract out AB. And if we take AC minus AB, we're just left with BC. In the scheme of the numbers, we would say that BC is going to equal length of AC is 6, minus 2 3/4 is really 2.75, easier to do with, so BC is just going to equal 3.25. Maybe I should highlight that one, and let me highlight this one because that's our end answer. Our last one does have x's in it, and I'm actually supposed to solve for x. Well, we have a whole, and we have 2 parts. So if I break it down letter-wise, AC is going to equal the part AB plus the part BC, and thus fill in the information we know. Well, we know A to C is 2x plus 5. We know A to B is length x, and we know B to C is length 2x. Now we just need to solve for x. So we're going to have 2x plus 5, add x plus 2x, and we're going to have 3x. I'm going to subtract 2x from both sides. Remember, what you do to one side, you have to do to the other side. And we'll be left with 5 equals 3x minus 2x is just x. X equals 5. And now we could easily get the length of A to B. A to B would be 5. B to C would be 2 times 5, which would be 10. And A to C would be 2 times 5, which is 10 plus 5, which would be 15. So we can use that to get the rest of the measures if asked. It just asked for x, so that's all I'm going to give it. All right, moving on. We have congruent segments. Congruent segments. A congruent segment is going to be dictated by what's called a congruent symbol. That symbol right there means congruent. Likewise, if you ever see that congruent symbol with a line through it, that means not congruent. All right, now we got the symbol straight. Let's talk about what congruence is. Congruent segments are segments that have the same shape and size. The good thing is every segment is going to already have the same shape. We're just making sure that they have the same size or length. So we look down at the example. The example says, well, D to E has a distance of 3 centimeters. It also says F to G is also 3 centimeters. So we know that these two lines are in fact congruent. They have the same distance between the 2 points. So we write this like this. We're going to put DE segment, because we're talking about a segment, is congruent to segment FG based upon those 3 centimeters. All right, sometimes we won't actually have centimeters or length on there. Sometimes we're going to use something called tick marks. Put a little note right here. Tick marks equals congruent. So an example of that might be you have a line here, and all I'm going to do is put a tick mark on each, and we know those two things are in fact congruent. Those tick marks automatically make them congruent. Another example might be have a line. We'll have a line over here. Sometimes, depending on how many lines we have, we might use more than one tick mark. We might put 2 tick marks, which means I'm going to match that up with these 2 tick marks. So 2 tick marks means I'm looking for the other one with 2 tick marks. Then they're congruent. If there's 1 tick mark, I'm looking for anything else that has another tick mark. And there might be 5 or 6 lines that have that same tick mark. They are all congruent. Match up the tick marks and you know which segments are in fact congruent. All right, so that's congruent segments. Distance between 2 points. We have 2 formulas for a distance between 2 points. We have the distance AB is going to equal 1 point minus the other point, or this point minus that point, as long as you take the absolute value. Your distance between 2 points is always going to be positive. This will always be positive. That's why we're taking absolute values. Now you might be thinking in your head, well, which formula do I use when? Well, I'm going to relieve some stress on you and say both will result in the exact same number. Both result in the same number. So it doesn't matter what order you do them in, you're going to come up with the exact same answer. Let's go ahead and practice that. So it says I'm looking for the distance between J and K. Note J matches up with -8, K with -3. It doesn't matter which order we put these in as long as we put our absolute value brackets. So I'm just going to go ahead and put the -3 first. So I got my -3 first, then I'm going to put my -8 next. So we are going to subtract. We are subtracting the other point, and that is a -8. This right here is going to mess many of you up. I don't care if it's negative, we're still subtracting it. And when you are subtracting a negative, it really turns into adding. So we actually have -3 plus 8. -3 plus 8 is going to equal a +5. Absolute value of 5 is 5. Remember, an absolute value, all it does is drop negative signs. That's all it does. All right, K and L. K lines up with -3, L with 1. In this case, I'm going to put my K first. So we're going to go with the -3 first, and we are subtracting 1 from that. Well, that equals the absolute value of -4. Absolute value of -4 is just a +4. So once again, our absolute value, all it does is it drops the negative sign. It turns everything positive. That's all it's doing. All right, the next one says determine if J, L, and KM are congruent. That means do they have the exact same length? So let's find the length of each of those and just determine are they the same or not. We'll do the length of JL. J matches up with negative 8, so we'll put negative 8 minus my L is 1, which is just going to equal the absolute value of negative 9, which is going to be a positive 9. Kn. K matches up with negative 3. N matches up with positive. Ooh, hang on. I'm talking about M. That's why I can't find an M. I'm talking about Km. All right, M matches up with a positive 7. So not plus 7, but we have to subtract 7 because we're always subtracting that number. And we're going to have absolute value of negative 10, which equals 10. These are not the same number. So 9 and 10 are not the same number, so it's not congruent. Not the same. So JL is not congruent to KM. If they were the same, they'd be congruent. They are not, so it is not congruent. All right, midpoints of a segment. Midpoints are actually a point that divides the segment into two congruent segments. So let's show kind of what that means. So let's draw a point right as close to the middle as we can. I'm going to call it point P. Now, point P, I'm going to tell you right now, is going to be a midpoint. So if P is a midpoint, that means AP and PB are in fact congruent. Remember, those little tick marks stand for congruent. Once again, those little tick marks stand for congruent. So if P is a midpoint, then AP must be congruent to PB. Midpoint means two congruent segments. You are cutting it right in half, creating two equal sizes or congruent sizes. Quick example. Down here it says that M is the midpoint of LN. Find LN. So if M is the midpoint, you can already see the tick marks on there. That means LM and MN must be congruent. That's the definition of midpoint. Midpoint cuts it right in half, creating two congruent segments. That means LM is congruent to MN, which leads us to the fact that x plus 9 must equal 4x. Now we just have to solve it. Just solve it by subtracting x on both sides. That will give me 9 equals 3x. Divide both sides by 3, and we're going to come up with x equals 3. Note, the original directions are find length ln. So we actually have to solve for this. So ln is our entire length. ln is going to equal lm, which is x plus 9, plus mn, which is 4x. That means ln actually equals, replace those x's with 3's. 3 plus 9 plus 4 times 3. And we're going to come up with ln equals 24. All right, bisectors of a segment. Bisectors of segments work just like midpoints. Basically, they're cutting things in half. We're just doing it with a line or a plane or something else rather than just a point. So a bisector of a segment is a line segment, ray, or plane that intersects the segment at its midpoint. So let's look at our example down here. So if we look at this drawing right here, we're looking at this line DC. Well, DC seems to be cutting AB into equal segments, which means M must be the midpoint of AB. So how we're going to write this? We are actually going to write, and it matters what order we do this in, we have to write CD bisects Well, CD is actually a line, so let's go ahead and put the two arrows on the ends. Line CD bisects segment AB. It has to be in that order because CD is the one cutting AB in half. If you switch the order, it doesn't make any sense. If you say AB bisects line CD, it's not what it's showing you. It's showing you that line CD is actually cutting AB in half. So we have to write CD bisects AB. All right, our next example says point T is the midpoint of RS. So let's look at T being the midpoint of RS. Well, that means R to T is congruent to T to S. So this distance is also 21.7. All right, find RS. Well, that's not too hard. We just wrote that in, basically. RS is just going to equal 21.7 plus 21.7. Well, that means RS is just going to equal 43.4. Easy enough. What's the next question? It says, what is the segment bisector of RS? All right, so what it's asking for is basically write the sentence. Write the sentence we did just before. So we're going to put VW, which is a segment, bisects or cuts RS in half. So it bisects RS. And that's all they're asking us to write. They're just asking, hey, write the statement of which is bisecting which. And VW is the one bisecting RS. All right, continuing on. Array. A drop of golden sun. Well, array starts and then goes forever. So it starts at an endpoint. Remember, a segment has two endpoints. Array only has one endpoint. It's going to start at an endpoint, and then it's going to go in one direction. So an example of array, it has one endpoint, and then it goes on forever. Just like a line, we are going to pick two letters to name the ray. However, you have to be careful on the notation on this. Remember a line, we could write either line AB or line BA. It didn't matter. This does matter. You have to make sure your endpoint is the first letter you start writing. And then B is the second one, and then we're going to put a ray above it. That is telling you that A starts the line and B is somewhere on the line. So note, our starting point matches up with that right there. You cannot, I'll repeat that, you cannot write BA. So I'm going to actually put that on there. Not BA. If you write BA, that's saying that B is your endpoint and A was your endpoint. B is the one that lets you know which direction it's going. All right, careful on those. Careful on labeling those. The last thing we're going to cover is opposite rays. Opposite rays. They're going to be on the same line. Which means they're collinear. They're going to share a common endpoint. That's important. And they're going to go in opposite directions. So, an example of that, we're going to draw a line. I know we're talking about rays, but we have to start with a line. Now what I'm going to do is I'm going to put a point kind of in the middle. Let's call it S. Put a point over here, T. And I'm going to point over here, R. Opposite rays. I'm going to color in what are our opposite rays. ST is a ray. Its opposite ray has to be, it's the only option, and that's SR. It has to be that because they must share a common endpoint. So S has to be the start of both of the rays, and they have to go in opposite directions. So our opposite rays are going to be ST and SR. Be careful how you label them. In ST, S is my endpoint, so I'm going to list it first. And S is my endpoint of the other one, so it'll be SR. I get the slight confusion. We don't write it like this. We don't write it like that. It kind of looks weird. We always start with our endpoint. Our endpoint is S, and and we go to the next letter. I know it's different than what's above it, but that's how we write it. So we have ST and SR are opposite rays. Cool. That's all we got for new material. Let's quickly go through some classroom examples and then we'll be out. All right, and we're going to kind of rifle through these. You should be trying these on your own, so I suggest you pause it, try them on your own, and then see if you got them correct. But I'm just going to kind of fire through them. All right, does the symbol represent a line, segment, ray, or length? Once again, pause this if you haven't answered these. Well, PQ has a line above it with no arrows. That is going to be a segment. PQ on B has a line above it with one arrow. It's got one arrow, which means it's a ray. Double arrows means it's a line. So C is line. Nothing above it means it is a distance. In other words, it's a length according to this problem. All right, continuing on. We're going to use that line for 2 through 5. All right, is AB the same thing as BA? Yes. They're the exact same segment. Remember, A to B are all the points between A and B. B to A are all the points between B to A. We're talking about the exact same thing. So, yep. Is ray AB? So let's highlight ray AB real quick. AB is that ray. And then it says, is it the same as BA? Note that BA is going to be the one that goes in this direction. Those are not the same ray. They're going in different directions. So that's going to be a big old nope. Is AB the same thing as BA? 2 lines, no matter which letters or orders you put it in, are always going to be the same line, so that's a yep. Is AB the same thing as BA? Is the distance going from A to B the same distance as B to A? In other words, if this is 3 centimeters, going the other direction will also be 3 centimeters, so that's a big old yep. All right, number 6, we're using the number line. Number 6 says, what are the coordinates of P and of R? Well, if we look at the drawing, P matches up with -2 and R matches up with 0. So I'm just going to put little arrows and say, well, P matched up with -2, R matched up with 0. Name the point with coordinate 2. So we look at 2, well, that works with T. So that one's going to be T. Next one says, find the distance of RS, RQ, and PT. Well, R to S is just going to be 1 unit. It just takes 1 unit. You can do that method where you do 1 minus 0 and take the absolute value. You're going to result in 1, 2. R to Q, once again, if we do 0 minus 1 and take the absolute value of that, that's the distance from R to Q. There are no negative distances, so that's going to be 1. And P to T, once again, if you remember that formula, it's the absolute value of 2 minus a -2, which would result in absolute value of 4, which is 4, or you can simply count 1, 2, 3, 4. All right, name 3 segments congruent to PQ. So P to Q is 1 unit long. So we can name any segment that's also 1 unit long. So we're talking about Q to R. We're talking about the segment R to S. And we're also talking about the segment ST. They're all 1 unit long. Name the opposite ray of SP. Well, SP, let's go ahead and highlight that in red. SP is this ray right here. The opposite ray must have the exact same start point. It just must go in the opposite direction. So we're talking about this one right here, that ST. So the opposite ray is ST, where S is my endpoint, T is the continuation, and so we put the ray just like that. Name the midpoint of PT. So that's that point that cuts P and T in half. So we just look at the distance from P to T. The distance from P to T we already said was 4. So cutting it in half is going to be 2 units on either side. It's going to be point R or 0. What is the coordinate of the midpoint of ST? The coordinate of ST, there's no letter that works for it. what we're actually trying to do is look at ST and what's halfway between 1 and 2, and that's going to be 1.5. Could you list all the numbers between 1 and 2? I couldn't, because there's actually an infinite number of them. All right, that's it.